Good afternoon, everyone. And I've been asked to talk about recarbonation. It is, I think, something that you already heard about, I'm sure. And in fact, if I go back to the presentation from Dinah earlier on, you can see that the last lever that we are lighting on how we can achieve carbon neutral concrete is actually recarbonation. Now, what we want to do here is to quantify what the recarbonation potential of concrete is, and then enhance it where we can through the recarbonation of construction and demolition waste. So that's actually one of the CCU option that was outlined by Magali, mineralization, that's how it was called. So I think this presentation really nicely links to the two previous speakers. Now, recarbonation is something on what we have a lot of research available. Research first, because in fact, recarbonation is an issue that structural engineers have been fighting for decades. So the mechanism of recarbonation are really well understood, and actually it is something that we wanted to prevent because that could lead to destroying the concrete structure. But still, the top layer of concrete recarbonates, and there has been over, I would say, the last 10 years or so, more and more research on quantifying this recarbonation potential of concrete and how much concrete in the built environment recarbonates. So you see on this slide all the studies, at least not all, but the main one on quantifying this research potential. There is an Irish study, a Dutch study, a Norwegian, a Spanish one. And then more recently, there was what I see as a breakthrough article in geoscience, and that was the one here, this one showing substantial global carbon uptake of concrete through recarbonation. And I think this is actually that article that triggered the sector to say, well, we have to quantify this and we need to get the numbers right, but we also need a methodology to quantify, and the methodology that will be recognized internationally. So the idea was to put together a bunch of scientists to develop a methodology that is compliant with IPCC methodologies and that would be accepted by UNFCCC as in fact recognizing the amount of CO2 that is reabsorbed by concrete. Also, when we decided to start the studies, there was already a European standard available. You see it on the top right corner. And that European standard, in fact, also allows to calculate then at the level of a product and at the level of an EPD, an environmental product declaration, allows to calculate the carbon uptake by concrete product. And in fact, recently, we have also updated the EPD tool, and as you see, the GCCA EPD tool, and as you see on this screen, in fact, this recarbonation potential is accounted for in the EPD, both at the level of manufacturing, while the product is stored after manufacturing, then a quantification of the recarbonation during the use stage of the product, so during the lifetime of the building or of the infrastructures, and then finally the quantification of the recarbonation potential at the end of life. So when there is a CO2 which is reabsorbed by the concrete, and finally even maybe when concrete is landfilled, which is obviously something we want to avoid. And this is really here that we can speak about enhanced recarbonation. So when we are speaking a roadmap, and we are obviously working on this, it's hard to increase the amount of CO2 that can be reabsorbed at the end of life of concrete. And there, concrete recycling is obviously essential. Now, how does it work with IPCC, and what are we doing here? So really objective, as I said, is to have this recarbonation phenomenon recognized in IPCC, which is the reference for CO2 emission reporting at country level and actually at global level as well. And it's different, obviously, than having it recognized in an EPD. And we need to ensure that IPCC endorsed the methodology so that what we have defined is credible. So a project was co-financed by Samantha, CEMBUREAU, PCA, initially the World Business Council for Sustainable Development and the CSI initiative, and this project was taken over by the GCCA. And I've just made here a quick calculation to show how important that issue potentially is for our sector. Cement and concrete industry stands today for about 7% of global CO2 emissions. I know there are a lot of numbers out there, but I'm following up closely emission inventories and so on, and I published a LinkedIn article last year, and I'm about to publish a new one, and I stick with my 7%. So we represent 7% of global CO2 emissions. And if we assume that 60% of this is process emissions, then the current uptake is slightly below 1% of total global man-made CO2 emissions. So it is important, but it's important as well that we calculate this right. The potential maximum uptake is obviously way higher because theoretically we can achieve a 75 to 100% degree of carbonation, because we know that this reaction can completely go the other way around. So the potential maximum uptake is absolutely huge, is more than half of the 7%. So very important issue. So how is IPCC reporting structured? So that's quite important to understand. So in the IPCC report, the countries will report their emissions and they will report their removals. So in the emissions, they have to report for cement industry separately process emissions and combustion emission. And what I have not highlighted yet is that actually the recarbonation happens in relation to the process emissions. So it's not the combustion emission where the CO2 is reabsorbed, it's actually for the process emissions that we have this phenomenon of recarbonation. This is the inverse reaction of the one that is happening in our kiln, in simple words. And actually those two sources of emissions are reported separately in IPCC guidelines. This is actually one thing that also leads to a lot of confusion about those 7%, because most of people only look at our process emission, or only look at our combustion emission, and not at the whole story. And there basically, we need then to link the recarbonation to the process emissions. And the intention is to do that under the item, the reporting item removals, because it's actually a removal of the CO2 from the atmosphere that is happening. There is a door open in the IPCC guidelines, because as you can see on the screen, IPCC actually already recognized that there is an issue that is not currently included in the methodology, but that may become relevant for consideration in the future. So that's the wording of the actual IPCC guidelines. So to develop the methodology, we have worked as IPCC does, which is in fact to work with a tiered methodology. So the way IPCC does to make global inventories is that you don't know all the details of everything. So you have a tier 1, which usually is a basic method where you use high-level macro numbers to estimate what the emissions are. Then you can do into a tier 2 assessment where you know a bit more details, or a tier 3, which is a very complicated methodology to calculate. And the famous IVL report, which we have had developed in this project, actually offers the 3 tiers methodologies. So you have the tier 1, the tier 2, and the tier 3 methodology. I think the focus now for us is on tier 1. It's already great if globally we could calculate this at the tier 1 level, and then we can start and refine in some countries where we can. So So this is to summarize what I explained. You have the emissions in the cement kiln, and then you have the uptake model, and the uptake is both in concrete product and then also in crushed concrete at the end of life. So those are the emissions and uptake, and this uptake is actually the reverse reaction of the calcination reaction that happens in our kiln. Now, for the tier 1 level, we actually need, and actually COSTUP, this is what we are doing in India. So we have now launched a project for calculating the recarbonation potential in India. The first step is to collect data on clinker production. Not necessarily easy if you have to go back to 1990. Then calculate what are the CO2 emissions related to calcination. That's slightly easier if you have the clinker production, but you also need to understand exports of clinker and cement, because this may change the balance. And then if you want to refine, you also need to understand where the cement is used, because obviously the recarbonation potential won't be the same for a structural application as for mortar used for rendering application, where the recarbonation is obviously higher. And then obviously the tier 1 methodology also offers to cater for the level of recycling of the concrete, which is also an estimation that needs to be done. So we are now collecting the data, and there will be a spreadsheet, and then we can try to calculate and then start talking to the authorities to use. So the tier 2 is a bit more complicated, as I explained. So we then would go for a tier 2 in more detail on the cement type, because all cement type 1 recarbonate the same way. We will go a bit more into the detail of what are the different type of concrete product and concrete used, and what's the amount of cement used in the different concrete product, and then also the surface area and the exposure type per cubic meter of concrete. Sweden and Denmark are trying to work along a tier 2 methodology. And I'm very pleased to say that Sweden is actually the first country who this year reported as a country recarbonation of concrete as a memo item in their report to UNCCC. So we already have now one country who has used this methodology and reported it. So advanced methodology is even more complicated, so I won't get into there. If you want to learn more about all the details and have the reference, you can just click on the icon of the report here, and you will land on the IVL page. IVL is also developing a web page where you will find a lot of information related to recarbonation. So to conclude, recarbonation is the reverse reaction of what's happening in our kiln. It's happening, it's true, it's not greenwashing. We are trying to quantify this on a scientific basis and have it recognized. If we push this further and we go for enhanced recarbonation, then we could even talk of CCU option, which is actually also compared to what Magali showed amongst all the use option we have. If you look at using the CO2 to produce a fuel, for example, in that case, the CO2 will be released. So if the CO2 is used to produce a fuel, at best you have a half reduction of the greenhouse gas potential. When CO2 is stored in the concrete, is stored there for time period that are equivalent to geological storage. So the CO2 is stored forever, I would say, in the concrete. So it's a use option, but it's a true storage option. And then let's not also forget, I love to finish on this, that concrete also delivers savings in our lives, transport, infrastructure, energy building. So there are more savings than just, or more carbon removals than just the recarbonation of our beautiful natural stone. Thank you, COSTUP. That's my last words.
Thanks. Thank you, Claude, for unpacking recarbonation and how this is going to be so one of the crucial cog in terms of our journey to net zero. In paucity of time, I would try to ask one question. There have been several questions coming in, but there is one theme of question which is about what steps have the association or other stakeholders taken to get consideration of recarbonation as part of our GHG accounting boundary? And when do you expect clarity from regulators or international think tank like IPCC or UNFCCC when recarbonation can be accounted in the net zero accounting for the sector?
It's a long process before we will have it formally in the IPCC guidelines reviewed, not only because we need acceptance, but because those guidelines are reviewed every decade, I would say. So I think it's a medium-term issue before we have it formally acknowledged in IPCC guidelines. It might be up to a still 10 years process before it's there. So I don't want to give you too much hope that it's going to be tomorrow, but it's going to happen, that I'm confident. But what we need to do now is have countries reporting it, because as I said, we have this door open in the current guidelines. We have a strong case and a strong methodology. And this is why I'm now working on having as many countries as possible doing the calculation and then initiating meetings with their authorities and their experts responsible for reporting to UNFCCC, so that as many countries as possible report this, like Sweden, as a memo item. And when we will have several countries having reported as a memo item, we could already dream of having it included in what is called the IPCC emission factor database, which is not the guidelines, but it's an emission factor database. And there we just need a few more case studies, and that could be easier and could be in the next couple of years. And then when we have it in the emission factor database, we will be ready for the next IPCC guidelines review.